Today, companies across different verticals have access to vast amounts of data. Yet, this vast array of data is as complex as it is valuable. It's derived from various sources, represented in different formats, and travel at varying speeds. Any delays in acting on this data can result in perishable insights, seriously impacting decision making, often at great cost to the organization. To help companies overcome the data ingestion challenge, DataTorrent has built application templates for some of the most commonly used data sources and data sinks. These application templates allow developers to ingest data from broad spectrum of data sources including Kafka, HDFS, S3 and write it to popular data sinks such as HDFS, Kafka and Cassandra. Easy to use, fault tolerant, these pre-built application templates enable enterprises to do build and enhance applications faster to accelerate time to market and build applications without the need for specialized coding skills and lower the cost of operational support. In this video, we will look at how to customize database to database sync app template. In the basic video, we already saw how to import the app template and how to configure it and launch it for the basic use case of copying data from one database server to other. In this video, we will try to go through the source code of that app template and make some modifications and see how you can add custom transformations using Apache Apex before you write data to the destinations. So the starting point is let me go to App Hub tab and let me open the database to database sync application. This is the GitHub URL for the source code. It's hosted on GitHub at DataTorrent handle in the app templates repository. This is the repository for the source code of all the app templates. As you can see, this repository is licensed under Apache 2.0 license. So you are free to fork this repository, clone this repository locally, make the necessary changes, redistribute it and things like that. To clone this repository, you can use this path. So I already have cloned this repository locally. This is the location where I have cloned this repository, and in that we have various app templates. Let me move to database to database sync app template. As we can see, here is the source code of the app template. This is the Maven project. You can import it in your favorite IDE. I will be using Eclipse for the demonstration. So I have Eclipse and this is the project which is imported over here. Let's have a code walkthrough for this app template. So this application.java under com DataTorrent apps package is the backbone of this app template. This application implements streaming application interface which is provided by Apache Apex. In that we need to give the implementation for the popular DAG method. This method accepts an object of type DAG and of type configuration. DAG stands for directed acyclic graph, so we need to construct one acyclic graph in which vertices are our operators and edges are the data streams connecting those operators. As our application is about database to database, I will be using JDBC input operator and JDBC output operator for this app template. So these lines shows that we are including JDBC input operator and we are saying dag.add operator API. Then we have dag.add operator for the JDBC output. Then for JDBC we need some store, so we are initializing that store with JDBC store, and then we are setting something called as field info mapping. So if we look at this method, we can see that there is a mapping from database column name to the Java field with the corresponding data type. So here is the format for the input table. So we have columns such as account number, name and amount. Account number and amount are integer, whereas name is varchar or string. So in the field info we have mapping corresponding to each of the database columns. Similarly, for output side we need to provide mapping from database columns to the Java object fields. So after we define the operators and initializing the stores, we need to connect these operators with a stream. So we are calling dag.add stream API, where we are connecting a stream from output of JDBC input operator to input port of JDBC output operator. And then we are saying that we are specifying the partitioning scheme for the input port of this output operator, and in the partitioning scheme we are saying that partition has to be in parallel, which means that for every instance of physical partition of the upstream operator, I need one instance of downstream operator. And then we have a commented code block which talks about the instructions for customizing this application. We will come back to this later. Next important file is Pojo event.java. This is plain old Java object, or Pojo as we call it, and we have three fields in this object: account number, name and amount, which corresponds to the respective columns in our source table. Since we are using this particular table which has three columns, our Pojo object is defined in this way. If you are doing customizations for your own schema, you need to add corresponding Java class which has mappings to the database columns. So This class has these three fields and getters and setters for those corresponding fields. Our JDBC input operator will read data from the source table and emit the data as objects of type Pujo event. So each row in the database will be one object of Pujo event. Next we have properties.xml. Properties.xml defines the mandatory property for these app templates which are dependent on the end user environment. So these are specific to your environment. So for example, we have specified the JDBC driver to be Postgres. But if you are planning to use this application for MySQL, you can specify MySQL driver over here. But make sure that MySQL is available on your class path. Next is database URL or the JDBC connection string. Then we have username, password for the input source. Then the table name from which to read the data. And then we have where condition. So by default it's blank, meaning it will fetch all the rows from this table. Again, for the output we have similar properties like database driver, database URL, username, password and table name. Properties text is having few other properties which are used in the test environment. So it has some defaults for few extra properties. Then we have application test. So in the setup method we are creating some tables, and then in this test case we are using local mode provided by Apex. This can be used for your application test and for debugging purposes. So in the local mode you can run your application. So it will run in the single JVM with the operators being deployed in the different threads. So we are running the application asynchronously and then waiting for output tuples, and once we get the output tuples we will compare the tuples with the original tuples. Next important files are configuration files. So we have two pre-saved configuration. One is cluster memory configuration, which is suitable for medium to large size clusters. The properties.xml had properties which are mandatory for the app template and which are very much dependent on the end user scenario. So those are like the must-have properties for launching the app templates. The cluster memory configuration, we try to provide default values which are good for most of the scenarios. So for example, we are saying how many partitions do we want for the JDBC input operator, or what should be the batch size, like how many records you want to process in a single query, what is the primary key for our input table, what are the column expressions if you want to give any, this property is very important. It is called tuple class. So all the operators which are dealing on the POJOs or plain old Java objects have this property on the respective ports. So for example, JDBC input operator as this tuple class attribute on its output port, and we are saying that the tuples emitted by JDBC input operator on the output port are of this type. Similarly, for JDBC output operator, we are saying that the tuples on its input port are of this type. Then it has few properties for the transform, which we will talk about later. Sandbox memory configuration is similar to cluster memory configuration, only there are some minor differences, so that to make it suitable for single node Hadoop clusters or DataTorrent RTS Sandbox edition. Let's go back to application.java. So we have our application defined in this particular method. Let's try to run the application test first. As we can see that our tests are passing, which means things are good. Now we are planning to customize this application. So for that, we'll introduce one transform operator in between JDBC input and output. The job of this transform operator is to transform the incoming object so it will look at the name field from the incoming object and convert it to the uppercase. So this is what we have specified in the expression map, that the expression for name is name to uppercase. Since we have introduced this new operator, we need to bake this stream connecting JDBC input to output and add two new streams. First is connecting JDBC input to transform, and second one is connecting transform to JDBC output. So we will replace this line with these two lines. So let me comment out this and let me add these two lines. So we followed the instructions given in this code block so as to add this transform operator. Now adding this transform operator is just for illustration. You can use any operators of your choice from the Apex Mallar library, or you can develop your own operators to do any custom transformations or custom processing before writing data to output. So we are done with the changes, so let's try to run the application test again. Tests are working fine, which means our changes are fine. So let's try to build this. So we will use the maven command, maven clean install. It will compile all the Java files and create one application package with extension.apa, and it gets created under the target directory. So if we look at, it's over here. So this API we need to upload it to DataTorrent UI console. So we need to go to develop tab. There are no application packages as of now, so let's upload the newly created application package. Let's click on the upload button. Upload might take some time. We will see the notification which says that the package has been uploaded with the link to the package details page. It shows the last modified time and the short description for this app package. So this is very similar to the app package which we imported from the app hub. Only difference being now this app package is customized based on our code changes and then uploaded to the UI console. So the steps to launch the application are similar. Let's do it once again. So we'll click on launch. Then we specify the name of the application, which I will keep it as default. From the saved configuration, we will use the cluster memory conf. And for default properties, you need to give properties based on your environment. So I will be using Node 35 and Node 70. So Node 17 is my output server and Node 35 is my source. If you scroll down a little bit, you will see the launch button to launch the application. We can see the notification which says that the application has been launched successfully. If we click on the link, we'll see the details page for this application instance. As we can see in the directed acyclic graph, now we have a transform operator added in between JDBC input and JDBC output. So this was the customization which we did by the code changes. Now we can see that tuples are getting processed. And if we go to the physical tab, we can look at the containers logs. So that's about it. In this video, we looked at how to customize database to database sync app template by adding the transform operator in between, but you can try out and try inserting operators of your choice for doing custom processing, or you can define your own operators and then add it to the DAG. Also, this app template, by default we are shipping Postgres SQL drivers, yeah, but if you have a MySQL driver on your machines, you can also try out with MySQL. For Oracle, connecting to Oracle, you might need some changes which are not available in this app package as of now. So for more details, you can refer to the walkthrough document of this app template. That's all. Thank you. So please visit App Hub page from your RTS installation and import application of your choice and try it out today. Goodbye.